Since this is my first video of 2022, I just wanted to start by saying Happy New Year, brought to you by me from there. So for this video, I'm going to be replacing the rectifier and voltage regulator on an Autotech Engineering 320 amp alternator. So yeah, let's get started. So the first step in troubleshooting the issues with this alternator is getting the plastic shroud off. So I'm taking a 5/16 socket and I'm unscrewing the bolts on the back, or the nuts on the back of the shroud. Now you may notice when I pop this guy off, comes off reasonably easy, is that it's already got the new voltage regulator on it because I forgot to record removing the shroud the first time I did it. So here it is. And we will carry on with the clips that I did record. So now what we have is the brushes that provide power to the armature and the field voltage, so that there's a magnet spinning inside the core of the alternator. I've pulled that piece off. It's this guy here. Those two carbon, these pieces in here. Let's see if you can see that. These pieces that are on springs, it's hard to see with my finger in there. They rub on the axle on these two copper rings. There's a positive and a negative. They create a magnetic field that spins inside of, it's a constant magnetic field that spins inside. It adjusts and fluctuates based on what the voltage regulator sends to it. This is the new voltage regulator. When we got this all apart, we discovered that this set of diodes on the rectifier had overheated. So the next step is to replace the rectifier. So I ordered a new rectifier. These are the backs of the diodes here. And then there's these ones here as well. And the first step to getting that off, of course, is to unscrew it, but then also to separate all of the leads coming off the stator. So the stator is all the wires you see inside of there. That's the stator winding. Stator. And that is where the electricity is collected into these pins, and then from these pins through the rectifier bridge to the positive lead here, and the negative, which is this piece here, which is also attached to the casing, so that it grounds the casing. And yeah, so the next step is to unsolder these. I've already started removing these ones. The challenge is that if you look here, the little metal tabs are wrapped around the leads and then soldered. So you can see here the leads are exposed and the tabs have been peeled back, and then on these ones they're still wrapped pretty snug and they're still soldered. So what I'll have to do is heat these up, remove the solder, and then peel them back so they look like that. And then I'll be able to pop the rectifier off the back of the alternator and throw the new one on. I don't have it yet, so I got a couple days to get that done for sure. Well, unfortunately, that didn't go quite as well as I would have liked. If you look into this burnt pile of mess, you can see, where is it here? Right here. That is one of the leads coming off of the stator, and it is too short to reach the new rectifier when it goes on. So what we're gonna have to do is hopefully extend it. Hopefully extend it, because this isn't gonna make it. It should be up at around this height. It's about ½ an inch too short, but you know, let's see what we can do. That there is a cooked rectifier. Now this is what I was. You can see that this lead here, which actually needs a little bit more cleanup, is significantly longer than this lead here. We might be able to, I mean, I'm sure we'll be able to make it work, but it's not ideal, that's for sure. Like I say, it's about maybe ½ an inch shorter. Anyway, that is the alternator with the rectifier taken off. That is the rectifier. So the next thing I learned, that when this particular lead overheated, or as a result of, I'm guessing, the diodes heating up, whatever, it also melted a portion of the rectifier, this beige insulating sleeve here, into the hole here. So I had to basically scrape it all out of there. So I dismantled the whole thing. I took the pins out and everything and took the whole thing apart. I couldn't get the pulley off, so I'm now at a place where I'm ready to put it back together. Ideally, I would get the actual stator off to solder an extension onto here, because I'm definitely gonna need more conductor than what is available there. Might have to modify. No, it'll be fine. I can get up to probably a solid 1/8 of an inch, so I can at least double what's here. Have a tab coming up to solder the rectifier onto. I'll just make sure it's a real good connection. So I'm going to reassemble and then solder that when the rectifier arrives. So I got to this point here. I pulled all the bolts out that hold the alternator case together. The next thing I'm going to do is pull the rear half of the case off, so that I can access the stator leads. Like I say, there's 2, 4, 6, but as you can see here, this one is not long enough. To get the back of the case off, I'm going to need to use this guy here that I just picked up today. We're going to pull the alternator apart so I can get at those leads. And on another note, this one's also on my bench now. I'm not sure what the problem with it is yet, but we'll get into that one in another video. So now I've got the puller tool in place to slide the bearing off the axle. I really hope that I'll be able to get it back on, because yeah, I mean, I guess it should work, be able to put it back on, but we'll see. Let's get it apart before we start worrying about that. Well, that came off extremely easily. I have some concerns with what I'm seeing right here. It looks like some burning. Might need to replace some of this, I think it's Kevlar heat protection here. I guess we could pull the stator right out of there and take a look at it, but that's your high output hairpin stator. And then there's your field magnet on the armature that spins to do that high output work that you need. I might have to actually replace this entire lead starting right where it is here, and then put some heat protection and insulation on it. The actual windings of the stator look fine, so I'm not concerned about that. But anyway, there it is, broken down. Let's get this thing fixed. So right now what I have is the stator. I believe it's a 48 turn 3-phase stator with 6 leads coming off of it. The one of the leads over here is too short, so I'm going to extend that. But before we get to that, this is the rectifier with the fried diodes on it. Got cooked, not entirely sure what happened to cause that. But that being said, Autotech was very good about sending me parts and stuff, very reasonably priced. So that is being replaced, and I believe it is in this box here because it's the only alternator part that's ordered from Autotech, and this is an Autotech box. So we're gonna get that out of the box here. Let's see what we got here. Oh my goodness. Well, it is very well packaged for the trip. And there you have it. A brand new copper rectifier. Now that looks pretty good to me. So I've extended that pin. It's quite a heavier gauge than the original, so I don't imagine there's going to be as much resistance. So theoretically the wire won't get as hot. I mean, the internal fan's spinning at probably 5 times the engine RPM, so there's a lot of air movement cooling the alternator off. But because there's a solder connection there, I don't want it to overheat. Anyway, now that I've slid the casing, the back casing on, the next step will be to put the regulator, or well, to bolt it and then put the regulator in place. So that is what I'm about to do. The next thing to do is solder the 6 leads to the conductors on the rectifier. You often see them clamped. I will probably solder then squish them while they're still hot, just to make sure we get as much contact as possible. push them over to the sides just so they're nice and pressed up against the copper rather than the insulator. Not that that's a necessary step, but it's not gonna hurt. And then once that's all done, we'll put the regulator or put the brushes on and then the regulator on after that. Brush assembly. So now that the rectifier, voltage regulator, and brushes are in place, the last thing to do, well, I'm going to have to take these off because they actually hold the cover on, but I want to clamp the tab from the voltage regulator onto the rectifier. So we're going to clamp that, take a closer look, and then solder it as well. This guy right there. Let's see if I got another one here. I know I do. Oh, there we go. The little guy right there. So now that the alternator is back together, we got to come up with some way to test it. So I'm going to try to get it hooked up to this motor. I've got it machined onto this pulley here onto a water pump pulley with a multiple groove belt so that I can mount the alternator and get it spinning, hopefully around 3,000 RPM at least, and then we can try to get the field voltage jumped with a power supply or something just to get started. If that doesn't work, then we're gonna have to get a car battery or something like that, but we'll give this a test and see what happens. So the first thing we're gonna do is turn on the motor and get this thing spinning. Do that. Now the next thing we're going to do is measure the voltage across the post and show that it's 0 right now, and then okay, let's see what we got. Power supply is not plugged in, 0 volts. And now let's see what the alternator is putting out. On here. Basically 0 volts. Just some inductance or something, I'm not even sure. There's no magnets, so it's not putting out any power. Now we're going to plug the power supply in and measure the voltage at these 2 electrodes here. Just to show that we have 12 volts. Okay, that turns on our circuitry. Now we can go like this. Great. Probe came out, that's fine. Power supply, voltage, 12.5. Then we're going to go to the ground is constant, so we don't have to change that one. See what we got at our post. Basically 0.66, nothing. Then we're going to take a positive 12 volts here. Let's just double check that. There you go, 12.59. We're going to tap that onto the post of the alternator here, and hopefully the alternator doesn't react too much, but it might. So now theoretically we should have 12 volts in our power supply, 12.59. However, we should have 14 plus on the alternator. 15.3. So now it's generating its own power based on recirculating its produced voltage back into the field, and then generating charging voltage for your battery. 15.3 is a little bit high, but it's certainly showing that the alternator is functioning and working, and that's not going to hurt your electrical system. I think up to 16 is fine. So yeah, it was a successful rebuild, and there it is. That's the new rectifier and new voltage regulator on the Autotech Engineering 320 amp alternator. Highly recommend Autotech. They've been super helpful with me getting this thing back together. And yeah, that is it for this video. I will be doing another alternator rebuild, or at least a voltage regulator replacement on a MechMan Elite. That'll be coming up in another video. So that concludes the Autotech Engineering Rectifier and Voltage Regulator replacement. Lots of other great videos on Mr. M Full Send. Thank you for checking out this one. Hopefully you will check out some of my other ones, maybe subscribe if you want. If you don't, that's cool too. Anyway, brought to you by Project Paper Chase Records and me, Mr. M. So yeah, have a great day.